So in this particular case, the hypothesis is two sides of a triangle are equal in length. Okay, so if these two sides of this triangle are equal in length, then two angles of the triangle are equal in measure. Now we haven't gotten into the geometry yet, but that's what that conditional statement is saying. And it is true that the hypothesis was true and the conclusion was true. So another way to say if P then Q would be all P are Q, or P implies Q. So we've talked about statements and compound statements and conditional statements, but now let's talk about reasoning. Reasoning is the process. There are a few different types of reasoning, but a process based on experience and principles that lead to a conclusion. And there are three basic types of reasoning. The first is intuition. Intuition is a gut feel. I kind of think it kind of feels right. I kind of think that something would be true. So a gut feel would be like, if I have this triangle and I break it into two triangles, I kind of have intuition that these two triangles are the same size. That would be intuition, but I've not proven it. It's just something that it seems like it would probably be right. And then we have induction. Induction is a way at looking at specific observations and experiments. So when you're talking about inductive reasoning, you look at all of the test cases in front of you, and from everything that you observe, it seems that something would be true. So if I had, here's a triangle and the sum of all the angles is 180, and here's a totally different triangle and the sum of all the angles is 180, and here's another triangle and the sum of all the angles is 180. It would seem that as many triangles as I draw, if the sum of all the internal angles were 180 based on this experiment or based on this observation, we would probably draw the conclusion using induction that the sum of all the angles of a triangle are 180. But what we want to use for geometry is deductive reasoning. With deductive reasoning, it's a reasoning process where you are actually able to prove, you can guarantee that your conclusion is true. It's a type of reasoning where the knowledge will guarantee or prove a certain conclusion, which is what we want. So we can prove that it's true. And in order to prove it's true, you must have a valid argument. A valid argument has at least two statements, and those statements are treated as facts. These are called the premises of the argument. And so on the basis of these premises, a particular conclusion must follow, and this is called the law of detachment. The law of detachment is, if P is true, then Q will be true. And if I tell you P is true, you know what you can conclude? Then you can conclude Q is true. That's the law of detachment. That's a valid argument, and most of our arguments are going to look like that in geometry. So let's look at a specific example of the law of detachment. Let's look here. Here we have two statements. Statement 1 is if a student plays on the Rockville High School boys varsity basketball team, then he's a talented athlete. That's a true statement. And then statement 2, Todd plays on the Rockville High School boys varsity basketball team. What can we conclude? Well, if a student plays on the basketball team is a talented athlete, and Todd plays on the basketball team, we can conclude, our conclusion is that Todd is a good athlete, a talented athlete. We can conclude that. So, there are many more examples, but let's go ahead and look at the formal reasoning. Here's the logical symbolism for the law of detachment and this deductive reasoning. We will see this pattern all the time, and I've actually already drawn this kind of for you. We're going to use letters to represent the statements. So P and Q are going to be statements, and they are true. For a valid argument, your premises have to be true. You cannot base an argument on false premise. So, if the first statement is true and the second statement is true, then you can conclude the third statement. This little symbol here is therefore. Looks like finger holes in a bowling ball, but that's therefore. If P, then Q is true. And if we've asserted that P is true, then we can conclude that Q is true. In other words, if P implies Q and P is true, we can know that Q must follow. Q must be true. So we're going to show an example of this and how you can prove this even using Venn diagrams. How would we represent if P, then Q in a Venn diagram? P implies Q. Or remember, all P's are Q's. Those are other ways to write the conditional if P, then Q. So here we have the set. Here's our set of P's. And if something is in the set of P, it is also in the set of Q. This is how we would draw if P, then Q, using a Venn diagram. In other words, P is a subset of Q. Of all the elements in Q, P is a subset of Q. So let's look at drawing our specific example, the one about Todd playing basketball here. Sets are going to be circles with uppercase letters representing their elements, and actual elements are represented with points. So, if a student plays on the Rockville High School boys varsity basketball team, then he is a talented athlete. So we're going to have, here's the set of all the students that are talented athletes. Talented. We would call that T. That's set T. Now there are a lot of talented athletes at the school probably. You know, they're the soccer players and the volleyball players, and there are a lot of talented athletes, but here's my subset here. Here are all the basketball players, the boys varsity basketball players. So if you are on the boys varsity basketball team, that is a subset of all the talented players. If you're on the boys basketball team, then you are a talented athlete. That's how we would represent statement 1 in a Venn diagram. Statement 2, Todd plays on the basketball team. Todd is an element. So here's Todd right here. Todd is a member of the basketball team. And since Todd is a member of the basketball team, and since all the members on the basketball team are talented athletes, we can conclude that Todd is also a talented athlete. So we've just finished preliminary section 2. Go ahead and have fun with your homework. Talk to you later. Bye-bye.